Binary operations, distributive property. So far, we have only considered one binary operation on a known empty set S. Sometimes a set can be closed under two or more binary operations. Suppose that a known empty set S is closed under the operation star and D. If for all A, B, and C elements of set S, A star B V C, like A operation B operation C is equal to A operation B operation A star operation C, then the operation star is set to the left distributive over the operation V. While if B operation C operation A is equal to B operation E operation C operation A, the operation star is set to the right distributive over the operation V. So it implies that here now in distributive property, in associative property, it usually involves more than two elements, that's three elements combined, where you combine two elements first before, then the result that you got from combining the first two elements, you combine it to the third element, and then there's a rule of associativity. But usually in associative property, there are three elements but the same operation. But in distributive property, there are also three elements which belong to the same set but two unique or different properties, two different operations. So like as you can see in this case, we have star operation and this operation. So this is what differentiates distributive property from associative property, where you have two unique operations and three elements. In associative operation or property, you have three elements and the same operation. So let's move on. Now, if for all A, B, and C elements of set S, A star B, V operation C equals to A star B, that means the operation A star C, then the operation star is set to the left distributive over the operation V. So if we have it this way and we expand A star B and then A star C, just like if you have your brackets, so you have 2 plus 3 times 2. Then you can see if in this case the addition operation distributes over multiplication operation. So we say the addition is left distributive over the multiplication operation, because the addition operation is on the left side but if it is let's say okay 3 times 2 plus 2, and of course this will give us 3 plus 2 times 2 plus 2, while in this case it will be 2 plus 3 times 2 plus 3 times 2 plus 3 times 2 plus 2, yeah, same thing. So if this we say that multiplication distributes over addition, so that means multiplication is right distributive over addition. Why? Multiplication coming first and addition is coming second, and addition is at the right side, or the position of the addition operation is the right, while in this case the position of the addition operation is the left. So whichever operation comes first, that operation distributes over the second operation, and it all depends on the position, whether left or right. But always note that the operation that comes first distributes over the one that comes next. So if addition comes first, addition distributes over multiplication, and if multiplication comes first, multiplication distributes over addition. So this will give us 3 times 2 plus 3 times 2 plus 2 times 2. So that's the implication. So multiplication distributes over addition, addition distributes over multiplication. So let's move on. Let's look at our example. So consider ordinary multiplication and addition on the set R of real numbers. 3 times 4 plus 2. If you go by what you have inside the bracket, 4 plus 2 is equal to 6. And 6 times 2 is 24. Let's see if it equals to, by the time multiplication distributes over addition, if that happens, 3 times 4 is 12, and plus 3 times 2 is 6. So 6 plus 12 will be what? Sorry, 4 plus 2 is 6, 6 times 2 is 18, 3 times 4 is 12, plus 3 times 2 is 6, 6 plus 12 is 18, so it's equal. But 3 plus 4 times 2, this is 4 times 2, 8, 8 plus 2 is 11. Let's say it is equal to what you have here when addition distributes over multiplication. So 3 plus 4 is 7, 3 plus 2 is 6, 6 plus 7 is 13. So addition does not distribute over multiplication, because here what you have here cannot be equal to what you have here. So while multiplication distributes over addition in R, a set of real numbers, addition does not distribute over multiplication. So in general, if P, Q, R are members of the set R, then P times Q plus R is equal to P times Q. When that means multiplication distributes over addition, so the P times Q close its bracket plus P times R. This is what you have here. So this is equal to this, but addition does not distribute over multiplication, so what you have here will not be equal to what you're going to have here when addition distributes over multiplication, which is this part of the equation. So this is proof 2. Okay, I think this one was from here. So then number 2, consider multiplication and subtraction on the set R of real numbers. 2 times 7 minus 4. Would it be equal to 2 times 7 minus 2 times 4? This is when multiplication distributes over subtraction. So 7 minus 4 is 3, 3 times 2 is 6. Let's see, so 2 times 7 is 14, minus 2 times 4, 8. 14 minus 8 is 6, so it's equal. But 2 minus 7 times 4 is not equal to 2 minus 7 times 2 minus 4. That's when subtraction distributes over multiplication, and this distribution is left distributive because subtraction comes first and the position of subtraction is the left, and that of multiplication coming next. So 7 times 4 is 28. 22 minus 28 is minus 26. Here 2 minus 7 is minus 5. 2 minus 4 is minus 2. So minus 5 times minus 2 gives us plus 10. And here is minus 26. So they are not equal. In general, if A, B, C members of set R, if A, B, and C are members of set R, then A times B minus C, that is X, is distributed over multiplication. Multiplication is distributive over subtraction. So A times B minus A times C. Discover that these two are equal from what we are proving here, but A minus B times C, which implies that subtraction is distributive over multiplication, or subtraction distributes over multiplication. So A minus B times A minus C, this part is not equal to this part. Hence, while multiplication distributes over subtraction, subtraction does not distribute over multiplication. So so we have summarization. Just having at the back of your mind that distributive property always go with two operations, two different operations, and it involves three elements. The difference between distributive property and associative property is that for associative property, we're going to have A star B star C, or A star B star C. So you see that it involves three elements, A, B, C. but the same operation, star star. But for distributive property is A star B V C. And this will give us is equal to E star B operation E star C. Or you can say E B operation C star E. This will give us B star E B star E operation B star E operation B operation E B star C B star C B operation B star E operation C star E. So what you can see is that for distributive property, there are two unique operations but with three elements. While associative property, the same operation but with three unique elements. The operations star and O are defined on the set N of natural numbers by A star B is equal to AB for all A and B members of N. AOB, which is A operation B, is equal to A over B for all A and B members of N. A does star distribute over O, B does O distribute over star. Solution. If star must distribute over O, it means it will be A star B C. That's what it implies. And this will give us A star B O A star C. So let's first of all simplify here. So first simplify. Let's simplify A star B operation C. Now A star B is AB. A star B is equal to AB. B operation C. For B operation C, A operation B is equal to A over B. So B will replace A, C will replace B. So here will be B over C. B over C. So A star B operation C equal to A. So you come by our general rule, since star distributes over O, that means we are going to follow this. A star B is equal to AB. So our A is A here, and our B is B operation C. So our rule is A. That will give us A times B operation C is B over C. B over C, which is A B over C. So now next simplify. A star B operation E star C. So A star B is equal to AB and A star C. This was a star of operation. Use this one, so our A is A, and here C replace B is formula, so it becomes A C. Now we say A star B operation A star C. Now this operation is This operation is A over B. So our A here is A star B, and B here is A star C, which now give us this pattern. So A star B is AB divided by A star C, which is AC. Okay, so now what do we see here? So we can see that A will cancel out E, so this will be left to B over C. Now this is check B over C, which is A star B operation A star C, is not the same as B over C, which is A star B operation C. So we say since AB is not equal to, so B over C is not equal to B over C unless B is equal to 1, but that condition is not met here. It's because it did not indicate so we cannot use this condition unless it is equal to 1. So it implies that A star B operation C is not equal to A star B operation A star C. So this hence star does not distribute. Star does not distribute over O. Then B does O distribute over star. So if O distributes over star, it means A and B star C, which should be equal to E operation B star E operation C. So let's simplify E operation B star C. So using this operation here, E operation, so our E is A, our B is B star C. What is B star C from? Okay, so now to get B star C, we're going to use this star operation. So here B will replace A and C will replace B. So if A star B is equal to AB, B star C will be BC. So B star C is equal to BC. So therefore A operation B star C is equal to A star O B star C. So because O is distributed over star, so we're going to use this O operation. And now if I use this operation, our E remains A here and B here. B star C will replace B here. So the operation is A over B. And so give us E over B star C is what? BC. So A over BC. Next, we're going to simplify this part. Next, simplify E operation EOB star EOBC. So EOB, using this formula here, EOB is A over B. Okay, when this star operation occurs, star is at the middle. So EOB is E operation B take the place of A here, and E operation C take the place of B here, and A star B is equal to AB. So A times that, so A right here, E operation B star E operation C. equal to where this is A and this is B in this binary combination. So A operation B is from here. A operation B, A operation B. So A operation B is AB, E over B times A operation C. What would be A operation C? A operation C. So A operation C, if A times B replaced by C, that would be just AC times AC. Why is it so? Because A operation C, A operation C, A operation B is equals to A over B. So if C replaces B here, that means here will be A over C. And we have A over C here. Now let's multiply, let's simplify. A times A is A squared and B times C is BC. Now what would you observe? You observe that A squared, this part is not equal to this part. So since A over BC is not equal to A squared over BC, unless A is 1, unless E is 1, you can see that E operation B star C is not equal to A operation B star E operation C. Hence O operation O does not distribute. Does not distribute over star simplification. The operations star and V are defined on the set R of real numbers by A star B is equal to A plus B, A star B, A plus B over 3, and A B operation B is equal to AB. So does the operation V or bar Z distribute over the operation star? So if this operation will distribute over star, it means E, so this will come first, B star C, and for it to be distributive, it means that A will multiply B and then star E and C. So let's see if this part is equal to this part. So first, for A by B star C. So B star C, come over here. B replace A and C replace B. So A operation, that will give us B plus C over 3 and that implies. Okay, so if we, so A operation B plus C over 3, which is this operation, that will give us AB. So where A is A and now B is this bracket. So this will give us A times B is B plus C over 2. That is A B plus BC over 2. And let's come over here. The A operation B. The A operation B is equal to E operation B star E operation C. Since V distributes over star, that tells us that we are going to use a star operation in this. And the star operation is a plus b over 2, where e is a star operation b and b is a operation c. Okay, so a operation b is eb divided by b is a operation c, where a operation c is equal to now a is a and now b will be replaced by c as a c. That will give us a operation c. This operation star is that's what we're going to have. Now forgot that there is operation star. So this operation star a operation b is a plus b. So where e here is a operation b and b here is a operation c. So our a, which is a operation b, and a operation b is ab. That will give us e b plus our b here is e operation c. That will give us e c over these two. So let's compare. You can see that this is equal to this. So since e b plus e c over 2 is equal to e b plus e c over 2, it follows that e follows that a b b star c is equal to e b star e operation c. Hence the operation redistributes over star on the set R. Given that a star b is equal to 2a plus ab and x star y is equal to x plus y minus xy, a, b, x, y members of R, evaluate 1, 2 star 2, operation 5, the solution. So since we have two unique operations, it clearly tells us that this is distributive property, where star distributes over the triangle operation or this operation. Okay, so let's begin. Figure 1. 2 star 2 5. So we're going to start with this bracket. 2 star. Now 2. This operation is x. X operation y is x plus y minus x. So this will give us 2, where x is 2 and y is 5. So 2 plus 5 minus 2 times 5. And this will give us 2 star. 2 plus 5 is 7 minus 2 times 5, 10. So this will give us 2 star. 12 minus 10 is minus 2. So now we're going to use the star operation. Star operation is a star b equals to a plus ab. So this equals 2, where a is 2 and b is minus 3. So 2 a is 2 plus 2 b is minus 3. Minus 3 times 2 is 4 plus 2 times minus 3 will give us minus 6, and which will give us minus 2. So answer to number figure 1 is minus 2. Number figure 2. Evaluate 2 star 2. 2 star 2 operation 2 operation 5. So let's get this. This will give us 2 star 2 using the star operation 2a plus ab. 2 a is 2, so 2 plus our b is 2, so plus ab times 2 times 2. Again, and operation here, e is 2 times 2 plus e, which is 2, and b, which is 5. And this will give us 2 times 2 is 4, 2 times 2 is 4, operation times 2, 4, plus 2 times 5, 10. This will give us 8, operation 14. So this will give us 8, operation 14. So now we're going to use this operation, and the rule of that operation is x plus y minus xy. So where x is 8 and y is 14, so this will give us 8 plus 14 minus 8 times 14. 8 plus 14 will give us 22 minus 8 times 14, 14 times 8, 8 times 4, 32, 8 times 1, 8, plus 3, 11, 112. So 22 minus 112, 22, 0. 11 minus 2 is 9. So minus 90, minus 90. That's the answer for this operation. Two binary operations are defined on the set R of real numbers by x operation y is equal to 2 bracket x plus y plus 2xy. Next operation y equal to 2x plus y. So we have two operations, and of course, so this is distributive property, but we are not going to prove whether this one is equal to this. We just have to follow the instruction as is given to us here. So A says find x operation y operation z. So this will give us x operation. We're going to get this operation first. Simplify this. Now y operation y operation z. So in this case, here we have x operation y. So our x will be y, will be replaced by y, and our y will be replaced by z. So if that becomes the case, we're going to have 2y plus z. That's what we're going to have. So next we are going to combine x to what we have in the bracket. So this operation is here. So x operation y. Now x is same as x here, then y is what we have here as y operation z. So the whole of this bracket is going to replace y here. So anywhere we have y in this equation, we're going to replace it by 2y plus z. So let's get our operation. So equal to x operation, so 2y. So in our equation here, x operation y, that's x operation y, so 2y, x 2y plus z. These are y. So here 2, this will give us x operation y is 2x plus y. So 2x plus y so let's simplify this part. 2x plus y, 2x plus y plus 3xy is 2x plus 2y plus 2x. So I'm going to put this here. So that will give us x. Okay. So x operation 2y plus z. So in this equation, anywhere we have y, we're going to put this part. So that will give us 2x, which x plus x here is whatever x stands for here. So we're going to put x here means whatever x stands for here, and y, anyway you see y here, we put this part. So 2x plus 2y, and our y is y operation z, which is 2y plus z, and then plus 3x plus 3x, and then 2y plus z. Now we're going to have 2x plus 2 times 2y is 4y plus 2 times z is 2z, 2z plus 3 times x, 3x times 2y gives us 6xy plus 3x times z gives us 3xz. And this will give us 2x plus 4y plus 4y plus 2z plus 6xy plus 3xz. So that's what this is what we got for this simplification of this operation. So b, let's see what b will give us. X operation y, x operation y star x operation c, expression c. So let's get x operation y. So this will give us x operation y is 2x plus y plus 11, which the simplified form is this. So let's also say x operation y. Now x operation y, same thing, x operation y. Okay, so now x operation y is 2x plus 2y plus 3xy plus 3xy 3xy plus 3xy, and then star x operation z. So this particular operation, well, z replaces y here. So where we have y in this equation, after we replace z with y, we will no longer have y in the expression, rather we're going to have z. So if here is x operation z, that means here will be z and here will be z. So let's replace it. So this is going 2x plus 2y plus 2x plus 2z, because it's x operation z, plus 3xz. Okay, so now we're going to carry out this operation on these two brackets, and x star y is 2x plus y. So where this is x and this is y, so 2x plus 2y plus 3xy plus y plus 2x plus 2z plus 3xz. So 2 times 2x is 4x, 2 times plus 2y is 4y, 2 times plus 3xy is 6xy, and plus 2x plus 2z plus 3xz. So let's see. So this will give us 4x plus 4y, 4x plus 2x, okay, 4x plus 2x, and then plus 4y plus 2z plus 6xy plus 3xz. This is 6x plus 4y plus 2z plus 6xy plus 3xz. Okay, so this was this is our final answer.